Blockchain is the backbone of cryptocurrencies like Bitcoin and Ethereum. But have you ever wondered how it works under the hood? In today's tutorial, we'll build a simple blockchain from scratch using Go. This hands-on project will demystify blockchain concepts like proof of work and block linking. Let's dive into the code. Create a new Go project and add these imports. We'll use crypto SHA-256 to perform secure hashing, encoding hex to convert the hash into a string format, FMT for printing things to the console, and time to get the current timestamp for our blocks. Now we define a struct called block. This struct is like a blueprint for each block in our blockchain. It has the following properties. Index, an integer to keep track of the position of the block in the blockchain. The genesis block, the first block, will have an index of 0. Timestamp, a string representing the time the block was created. This helps ensure the chronological order of blocks. Data, the actual data the block holds. In our case, it'll represent the transaction information for our cryptocurrency. Prevhash, the hash of the previous block in the chain. This creates a link between blocks, making it tamper-evident. If someone tries to modify a block's data, it'll change the hash, and all subsequent blocks referencing the wrong hash will become invalid. Hash, a unique identifier for the block. It's a cryptographic hash generated using the block's data and other properties. Nonce, a random number used in the mining process, which we'll discuss later. We also define a method called calculateHash for the block struct. This method takes all the block's data and calculates its hash using the SHA-256 hashing algorithm. The hash is then converted to a hexadecimal string for easier readability. Next, we have the mineBlock method, also within the block struct. This method is responsible for the crucial process of mining a block. Mining involves solving a mathematical puzzle to validate the block and add it to the blockchain securely. Here's what happens in the mineBlock method. Difficulty validation. First, it checks the difficulty parameter. This value determines how hard it is to mine a block. Higher difficulty means more leading zeros are required in the hash, making it computationally expensive to find a valid hash. Target hash. A target string is created based on the difficulty. It'll be a string with the specified number of leading zeros, followed by any characters. Initial hash. The method then calculates the initial hash of the block using the calculateHash method. Mining loop. The core mining process happens here. It enters a loop that keeps incrementing the nonce value and recalculating the hash until a hash is found that meets the difficulty criteria. The nonce acts as a random number that slightly alters the hash output. Hash check. In each iteration, the beginning of the hash, specified by the difficulty level, is compared to the target string. If they match, it means the block has been successfully mined, and the loop breaks. Success message. Once a valid hash is found, the method prints a success message to the console. Now let's move on to the blockchain struct. This struct represents the entire chain of blocks. It contains a slice of block pointers, effectively storing the entire sequence of blocks in the blockchain. We have a function called createGenesisBlock to create the very first block in the chain, the genesis block. The genesis block has a special status. It has no previous block, so its prevhash is empty. The addBlock method is used to add new blocks to the existing blockchain. This method does the following. Get previous block. It retrieves the last block in the current chain. Create new block. It creates a new block with the provided data, the current timestamp, the index of the new block, and the hash of the previous block. Mine the block. It calls the mineBlock method on the new block to perform the mining process. Append to chain. Finally, it appends the newly mined block to the block's slice of the blockchain. The printBlockchain method is for displaying the contents of the blockchain to the console. This method iterates through all the blocks in the chain and prints their properties to the console for easy inspection. Finally, in the main function, we put everything together. We create a new blockchain instance, initializing it with the genesis block. We add 3 more blocks to the chain using the addBlock method, specifying a difficulty level of 4 for each block. We call the printBlockchain method to display the contents of the entire blockchain to the console. Now let me brief you with key concepts. Block structure. Each block contains its position, index, a timestamp, data, and the hash of the previous block, prevhash, ensuring immutability. Hashing. Cryptographic hashing ensures the integrity of the data within each block. Mining. The process of finding a valid hash for a block, involving computational effort. Chain structure. Blocks are linked together sequentially to form an immutable chain. Each block links to the previous one via its hash, forming a secure, tamper-proof chain. If you run the blockchain, you'll see the mined blocks with their data and hashes printed to the console. If you enjoyed this tutorial, you will definitely love to watch other quick coding challenges on this channel. Let me know what projects you'd like to see next. See you in the next one.